Alright guys, I'm back. Let's try our node once again. I hope this time it runs. Okay, nothing's happening. Our node is dead. Or is it? Yes, it is. Anyways, let's get back to our. We'll use something else. I guess we can use this. We were in a contest, right? What? Did they end my contest, man? What the hell? No way, man. No way. Contest going on. Yes. Thank you. Anyways. Yes, please. Thank you. So we have, let's say, the test case was what? It was 3, 1, 5. The indices are 1, 2, and 3. So we add the indices, then we check the product. Right? That's a very brute force way to solve this. We need any better way. So what we can do is we have i's and j's, right? So I can be from 1. Let's first start writing our values for I. So I can be 1, 2, 3, 4. Let's say n is equal to 4. So j will be 1, 2, 3, 4, right? Now if I choose I as 1, j can't be 1. It will be this. So 1 and 2 is 3, 3 and 1 is 4, 4 and 1 is 5. Now if I choose I is 2, so it can neither be this nor this. Is starting from here, right? So it will be 2 and 3, which is 5, and 2 and 4, which is 6. And similarly, it's not going to work for all these. It's only going to be this. So it will be 7. Let's now try with 315. Now I can be 1, 2, 3, j can be 1, 2, 3, or can it be? So when I is 1, j can be this. It's going to be 3 and 4, and then we have this, so it becomes 2 and 3, 5, and then we have nothing here. So the values are 1, 2, so the values are going to be actually, the products are 3, 1 and 5, right? So 3, 1 and 5. Now if we do multiply this, So 1 and 1 is 9. Right, so 1 and 2, we have 1 and 3, which is 15. This has very easy brute force solution, but right now the problem is in so they have guaranteed that all elements are distinct. Okay, so what does that mean for us? That means that there will be only one pair of I and j, such that so there can be a pair of 1, 4. Then we can have also a pair of 2, 3, which can have the same value, right? How am I supposed to solve this, man? So this is actually a decently hard problem. 2 and 1 is 3. 2 and 2 is 1. 2 and 3 is 5. 3 and 1 is 15. Let's actually just not do these and be smart about it. Let's not do this, let's not do that, let's not do that. Let's not do these either. This is what we're left with. Answer is supposed to be 2, but our answer is 3. I don't know why. So 1 dot 1 2, 1 5 and 2 3. Wait a minute, wait a minute. I was looking at the wrong problem. It's right here, it's not a problem. Oh, 3 1 5 9 2. 3 1 5 9 and 2. So it's going to be okay. What if how are we supposed to build these pairs, man? How are we supposed to do this? So what if I build something like a set or something like that, and then I insert these values, and then we check certain pairs whether or not those pairs have the same indices. So start from 1 and we go to 2, and I guess, right? Because the largest sum can be what? Can be 3 plus 2 or 4 plus 3, which is 2, and right? So we'll try to look for sums and products. So okay, now here's the thing. Mm-hmm. We have two numbers, right? Like these, any pairs. How the hell are we supposed to find? Let's think about. The hard problem. Uh, how can we check this? How can we check? The indices are supposed to be 1, 2, 3, 4, and 5. It's like any two numbers. It's or this or this or this.
We are leaving some.
So we have sums, and it's so weird, man. How are you supposed to solve this? O of n or n log n? Um, so we don't know these two values, right? You can also write this as a of I into a of j to percentage of sum is equal to 0. So no, we can do that. Yes, we can do this. A of I into a of j. Then we say, so I think this has something to do with this being distinct, the elements being distinct. Because let's say that, let's look at this test case, right? So let's look at this test case. 6. Sorry, it's actually 31592. These are the values 1, 2, 3, 4, and 5. So this and this work. So this is 1 and 2, right? So it's 3, and this part is also 3. So we can say that a of I into a of j is equal to I plus j, where if the elements are distinct, this means what does that mean? Does this mean that each product is going to give us a different value, or would there be a difference in terms of number of values with the same product? Let's say I have a product of 10, I guess. Let's say that I plus j is equal to 10. So if a of 2 is equal to, let's say, 5. So this side is equal to 5. Then we have a of 10, let's say, is equal to 2, right? Or similarly, a of 3 is equal to 3, and then a of 4 is equal to 12, right? So this is very much possible. This, despite having distinct numbers, two different products of ai and aj can yield the same sum. Sorry, the same product, right? Product remains the same, and obviously different indices can also contribute to a similar value of sum. Now that is now that that's out of my mind, let's say that I choose a particular value of ai, right? And this is also something that I've chosen. Now, is it possible that AI is equal to I plus J divided by AJ, right? And let's say I know the sum, okay? I know a particular value of sum. Let's look at it the other way around. Let's say I have AI times AJ sum, certain value of sum, right? Now, can I so I will brute force for the sum, and then in that brute force I try to find two particular values of AI and AJ. So is that possible? Hmm. So this would be a very number theory based problem, because then we are supposed to find all the factors of that sum. Factors of that sum, and then we decide whether or not does a particular pair of factors exist. Does a particular pair of factors exist such that this is a number theory problem now. And the values of AI are supposed to be what? They are smaller than 2n, and the value of n is 2e5. So we can build an array. This is very much doable. So value of n is 1e5, and we try to find the factors of that sum. Do certain particular factors exist or no? If they do exist, where do they exist? Okay, and since this is a distinct value problem, right, we can actually check whether or not the place at which they exist wait a minute. So how are we supposed to do that exactly? We're going to say exists a particular factor, right, at this place, this index. So if a factor exists at this index, this means that we can check this as well. We can check index this and existing factor something else, and we can sum that, and we can check if that sum, if that is actually equal to the sum itself, right? This right here is actually equal to the sum. So how do we build factors in the first place? Now if so We can just have prime factors, and out of those prime factors, we have to basically group those prime factors in any shape or in any way or form. So how are we supposed to do that? This does not look like a 1200 rated problem at all. So we are going to iterate all of those factors, right? So we can basically build a set of those factors using an LP array, I guess, and we're going to iterate through that LP array using a bit mask. So once you get a set of those factors, pairs of factors, then we can check whether they exist or not. All right, so how much time do we have left now? We have an hour left, so we are running late actually. I was expecting to be able to solve this quickly. So 2e5, is this problem doable? I think so, yes, it is. Because we build an array of factors and we just iterate to the sums, right? So okay, now so we are going to have this one. And we're going to say vector, sorry, we're going to have so we're going to have an array of lowest primes, right? So it's going to be a vector and vector of vector of vector, and this is going to have LP of size of n, right? And yeah, that's pretty much it. We don't need to initialize anything else. And also, we are going to have we're going to say for if I is equal to 5, less than equal to less than n I plus, right? So if LP of I dot size is equal to is greater than 0, so we continue, or do we? So one thing to understand is that so we can have one, I guess. So we can actually go through the mask, right? And is there any shorter way to solve this problem? We need to find factors. So we can just you know what, let's just not do this. So we're gonna say if factors of size, sorry, we, say, or it's going to be 2x. If j is equal to what? Is equal to I, j is less than n, j plus plus. So we're gonna say, sorry, it's going to be j plus equal to I. What the hell? I, so I, if I percentage j equal to 0, and the factors of I dot push underscore back, and push this in there, right? And then we are going to once do this, we have all those factors, right? Once you build those factors, this is going to be in n log n, right? And then we come here and we say int n c in values vector in size of n plus 1, right? Like this. So initially it does not exist. Oh, sorry, it's going to be a map actually. Map of int exists. And we are going to start from we're going to say that to prevent any duplicates from happening, we're going to build a set, right? That's pretty understandable. Would that affect time complexity? A little bit, but I think we should be fine. So we're going to start from in x, right? Sorry, it's going to be this. I'm going to say exists a of I, and then we check. So this is what happens here, and then we are going to go for int sum is equal to whenever true, sum is less than equal to 2 times n, sum plus, right? And then we check, okay, we're going to find the factors now. Set of a of int p pairs is false pairs, and say so you're going to find the factor of that sum, right? So how do we do that? We're going to iterate through their I get it. I got it. So for auto comma factors of that sum, and then we say pairs dot insert, and we first insert the minimum of x, the factor itself, and factors, then we say sum divided by x, then we insert maximum of so is it possible to have duplicates in such a manner? No, man. Let's say that it's not possible. Very good, very good. So we say x and sum divided by x, right? And we insert this into the set of pairs, and there will be no duplicate pairs in this manner. And when we iterate through that for auto p in give me a second. There's someone outside. All right. So we iterate through. Now, how do we iterate there? I always forget this line of code. What the hell, man? This is why AI is not going to take over. So we're going to iterate through these pairs, right? And we say that what do we say? We say that if exists at p dot first plus exists at what else? In third case is that they exist but the sums are not good enough. So exist at p dot first, right? So where the first factor is located and where the second factor is located, the places where they're located does not equal to sum. Then we otherwise we right. I think that is how we solve this. Some weird error, so we just messed something up. I think we okay. The fuck is this the problem? No. Why is it not working? What the hell did I just do? It was so stupid. It's supposed to be a pair, man. What the hell am I doing? Bismillah. Oh no. Ho ho ho. I never calls you. That's true. Oh no. Don't do this to me. Don't do this to me. I want to solve the 4800 today. I had to solve it, man. Submit, please, please. So there is something going wrong right here. Runtime error is happening. So why is there a runtime error? Out of bounds on line 35. Okay, all right, all right. So I think I get it. I get it. It's supposed to be. Because we need factors up till 2n, right? So that's why it should work now. Oh, that's it. So the sum can start from back to 0 from 1. Still numbers are different. Shit. Dude, why am I getting a wrong answer, man? So exists are 0, 0, and are equal to sum. We continue. So I think I figured this out. I think we are forgetting that if wait a minute. So we are also supposed to do something like this. So if sum by x equal to x, then continue. Why? Because there are no two factors that are the same, right? So we can just dodge this problem for the case of 1, I guess. Okay. I'm still struggling with the plus 1 related problem. So yes, let's go. Let's go, baby. Got this, man. Go. So we have 30 minutes left. We need to solve the 1400. Let's go. There are n workers and m tasks, right? So there are n workers and m tasks. Each task I has a value AI. So there are n workers and m tasks, and each task I has a value AI, and the index of worker who is proficient in this task, right? So each task I has a value AI. Right? So we have a value AI of each task, and the index of the worker who is proficient in the task. So this is going to be the best guy for the task, for that task. So every task should have a worker assigned to it. Hmm. Second line m contains integer, right? So a1 till am. Okay, okay. So we have two workers. In the first example, we have two workers, and let's see. So we have two workers, and there are 1 2 1 2. So 1 2 1 2. Now first guy, we have person number 1 and the person number 2. So person number 1 solves this problem right here. Okay, so the problem at index I of 1, right? And we're going to solve this. Actually, let's exactly do it in this manner. So we have person 1, person 2, right? And we have hours here. So 1 hour, 2 hour. So in the first hour, this person solved the task 1. Second hour, he solved this task. Person 2 solves this task here, right? So, and then the second attempt is going to solve this task. So, okay, we can choose this, we can choose any of them, right? And there are going to be tons of edge cases which we need to work on. So we have two workers and we have 4 tasks, and we have 1 and 2. So 1 1 1 1. Now the first guy completes this in 1 hour, the second task is completed in second hour, and then you realize that this guy right here is saying idle. We can just give him 1 task, that is for this guy, right? And then we have 1 task remaining, we can just let him complete this. So this guy completes 3 tasks and the other one does 2. Sorry, the other one does 1, and we get 3 as the answer. This right here is the edge case. How are we supposed to deal with this? Now the ideal way to solve this is by So we can think about it. How can we think about it? How the hell are we supposed to solve this? So once we have this, we can think about it in this manner. We can think that first guy guessed this, the first guy also guessed it, right? Second guy has the second guess. Now, how do we figure out that some guy is sitting idle? Okay. And give me a second. Okay. How do we know that, let's say that some person is sitting idle, right? That I am saying idle, and there is someone else out there who is working a lot. He has a lot of tasks that he is very good in, and what we would actually do is give this guy that task, right? So we can think about it in this manner. We can think that we can find the people that are idle and just hand them tasks, right? Let's say that we have these many tasks to do, right? We have 1, 2, 3, 4, something like that. So the first priority would be to give each guy their task. Okay, I can give him this task. The first person gets the task 1, the second person gets a task 2, the third person gets a task 3, and the fourth person gets a task 4. So that's good. That's good. But for the second hour, we need to identify how many people are staying idle. This will actually also get passed to this man right here. Why? So here's the thing. If some guy is busy, we actually have an hour. So if some guy is busy, just assign him some other guy's task. Doesn't matter, or does it matter? That's the question. So 1, 2, 3, 4. Then we come here. We say, okay, now 3 is busy because the last time he did a task was in the previous hour, and he was an expert in that task. Now we have another 3 sitting around. We can just hand him that task, right? And we can say that the answer is 2. The hour was 2, right? However, we have 4 here, so we can assign that as well. That becomes 4. But
What's in me?
live stream. So we can actually just figure out if some guy is saying idle. The first and foremost priority would be to hand this to some guy that knows their stuff, right? So we'll hand this to this guy, we'll hand this to that guy, we'll hand this to this guy. And then we are going to figure out that we are still lacking some information that how are we supposed to iterate through this. So I'm thinking that we iterate it by the people, right? So we iterate this in let's iterate this hour wise. That's my approach, because hours can be at worst 2 times n, and in that case I think it's very much possible. So iterating hour wise makes much more sense to me. So the value for n is 2 so 2e5, so we're fine. Now the question comes, how are we supposed to figure out assigning the problems, right? So first thing, we need to give this to someone who knows their stuff, right? If the guy that knows their stuff is not available, what do we do? We can actually have something called free guys in that hour, and we can say that, okay, this free guy is doing that guy's task. So that means let's say that we had a 3 here, right? And then let's say we have another 3 here. So we can say that these 2 are free guys, okay? Free guys for this particular hour. And that free guy gets to do, because these guys have done their own tasks already, right? And then these free guys get chosen for a certain task. We can say that
मैं थोड़ी सी गाइड कर दूं आपको
So at this point, we can have a set that stores the ith task, and we can remove that particular task at each stage. We can also store we can store the ith we can store the data about the ith person and the task they did at a certain hour, and that's how we are going to check whether or not they are done with it, basically. So and then we check. We have blocks. I think we did a very wrong approach. This was not how this was supposed to be solved. This was, oh, we have blocks now. Let's think about this blockwise. Now, 1, 2, 1, 1, sorry, 1, 2, 2. So we have 4 total tasks. 4 tasks. And 2 people. So expert of 1. There are 2 tasks that this guy. So we have nothing. There is not an imbalance. Let's say that. The tasks are 4, expert of 1 is equal to 4, expert of 2 expert of, so imbalance here. We can also these tasks. We can actually offload these tasks, these 2 tasks and these 2 tasks right here. So 2 tasks here, 2 tasks here, and it's going to cause a problem, right? So we are supposed to actually just add 1 task. So a single task here, and this single task gets us 2 hours and this gets us 3 hours. So the imbalance is supposed to be off. Imbalance is actually of 1, so that 1 task is here. Now let's say that expert of is 10 tasks, right? And expert of 2 and 0 tasks. So we are supposed to solve the same balance. Now we're supposed to solve this. So the ideal would be that we have every 2 tasks we get someone else. Every 2 tasks we get someone else. Every 2 tasks we get someone else. I think this is it. I will take a break and we will get back to it. So I'm going to call this off now.